Hi good people, Titus here for a new Unreal Engine series where we attempt to recreate the classic arcade game, Qbert, in 3D. The original Qbert was released way back in 1982 and was a 2D isometric puzzle game where you control Qbert and hop diagonally to flip tiles to a uniform color while avoiding enemies such as Coily the Snake. Alright, let's hop into part 1 of the series where we create Qbert and set up the movement system for our player pawn. Alright, this is going to be using the third person template. I'm going to create 2 folders. The first one is going to be my Blender folder, and the second one is going to be my Blueprints folder. Inside Blender, I went ahead and modeled a static mesh and I did some basic animations. So I'm just going to drag that in here. I'm going to check the box to import the animations. But you can use any static mesh or any animations you want for this example. With that done, I'm going to go to my Blueprints folder, create a new Blueprint class. I'm going to use the character preset, call it BP_Qbert. Now we are coding our own movement, however the reason we're using the character movement script is because it has gravity. So we're going to be using gravity to pull Qbert down. I'm going to select the mesh on the left, come to the skeletal mesh on the right, and select Qbert. It's a little big, so I'm going to lock in the scale and set the scale to a 0.3. And that looks a little bit more reasonable. The capsule component looks a little tall, so I'll select the capsule component and select the half height to 50. Then I'm going to select Qbert again, come to front view, and then I'm just going to drag him so his feet touch the ground inside the capsule component. Then I'll come back to perspective. Now we don't have a camera set up, so we're going to need to do that next. Make sure your capsule component is selected because that should be the main parent of everything. Hit add and select a spring arm. With the spring arm selected, hit add again and choose camera. We want the camera to be a child of the spring arm and the spring arm to be a child of the capsule component. With the spring arm selected, make sure your target arm length is something a little bit further back, like maybe 900. We will also want to get rid of do collision test. This will make it so the camera doesn't move or flip positions if Qbert gets behind a block when he's falling. And then let's adjust the rotations. I'm going to set the Y to 330 degrees, and I'm going to set the the Z to 270. I want to see how this looks in level, so I can come to my project settings, select maps and modes, set the game mode, and change the default class for the pawn from the template to the BP Qbert that we just created. Now I can come back to the map and hit play, and that looks about right, so I think I'm okay with that. Coming back to the event graph now, we're going to get rid of the overlap and tick. To drive the movement logic, we need 3 variables. The first one is going to be a isJumping boolean, because we don't want to jump if we're already jumping. And then to move Qbert from one position to the next, I need 2 locations, and I'm going to use 2 vectors to do that. So first vector is going to be current location, and then the second vector is going to be forward location. Now I need to set the current location when the game starts, so I can hold the Alt key and drag current out, and then I can hook this up into here. Now to get the position, remember everything is childed to the capsule component, so we can actually use the capsule and get the relative location, and then we'll use that to plug into our current location, and this will execute when the game begins. With that out of the way, we need to drive the logic for the keyboard input. I'm going to use the classic WASD keys to drive my movement, so I'm going to set up some keyboard events for those keys. All right, we have our keyboard events set up. So now to actually drive the movement and the rotation, we're just going to be using two functions. The first one is set world rotation, and we're going to be rotating the static mesh, which in our case is Qbert. Now to actually drive the movement or the translation, we're going to be using set world location, and we're going to be doing that on the capsule component. And just for, I guess, demonstration, so essentially Qbert, the static mesh, we're rotating that around, but we're actually moving the capsule component from one position to the other, and then Qbert will follow the capsule component because he's a child of it. So that's the general logic anyways. But we need a little bit more to get this to work. So I'm going to split this structure pin. And starting off, move this back a bit. I'm going to hold B and click into the graph, get a branch node. I'm going to get the is jumping, so I'm going to hold Control, drag it in. And off that pin, I'm going to do a not Boolean. And then I'm going to hook this in, into my branch check. So basically, if is jumping is not true, then I want to set is jumping to true. So I'm going to hold Alt, drag that into here, hook this up like so, mark that true. And this logic, the only reason we're doing this is just so the player cannot jump while they're in midair jump. So basically no double jump. And then after we do that, we can set the rotation of Qbert. And currently we're just going to be messing with the Z-axis. We're going to be rotating him depending on which key we push. So W is up, S is down, A is left, D is right. If you look at the viewport, Qbert is facing us right now, and he's at 0 degrees on the Z. Normally, you would turn your static mesh to face your movement arrow component, but because we're driving our own movement logic, that's not necessary in this particular example. I mean, you can set it, it won't hurt it, it just is irrelevant. So, looking at Qbert, 0 degrees, and you can see the axis in the bottom left, so X is kind of going this way to the right, and then Y is going back, and then of course Z is going up. 0 degrees and 360 degrees are where Qbert's facing now, which is looking towards us. And I would equate this to the S key. We push S key, you should be facing towards the camera and jumping towards us. If we push the W key, we should see Qbert's back, and he should be jumping away from us. If we rotate Qbert 90 degrees, he's going to be facing left. If we rotate him 180 degrees, that's how we'll get his back. And if we rotate him 270 degrees, that's how we get him to face right. So hopefully that made sense. So on the Z-axis, when we push W, I'm going to set that to 180 degrees. And then to actually drive the logic of the movement, we're going to be using the set world location, but we need the forward location evaluated. So we can hold Alt, drag in to actually get a set. And then we need the current location, so we'll hold Control and drag that in. So we're going to take the current location and we're going to do some addition. So we'll do add. And we'll plug that result into the forward vector. And then that forward vector will be given to the world location to transform the capsule component into the new position. So with Qbert, we're going to be setting up the map in a later video, and it's just going to be a bunch of blocks. Each block is going to be 100 units, so, and that's just to make things easier for us. So when we're doing rotations or we're doing movements, we only have to translate the actual character across 100 Unreal Engine units. So in this case, if we're pushing W and Qbert's going away from us, that's going to be in the Y-axis, and it's going to be negative 100 units. Now we want to make him look like he's jumping, so we want to basically move him up 150 units. And it's going to look a little weird, but if we compile and save, you can see that that actually worked. Now I can't jump a second time because we forgot to set the new location. So and the is jumping to false. So we can come off into a delay and then wait a half second. And then we can come into a current location. So we'll do Alt, drag this in. And we're going to do the same thing we did with the event begin play, where we can just drag in the capsule component, get the relative location, which is the new forward position technically. And then we can also set the is jumping back to false. So now I should be able to move forward through the map like so. And that's the basic movement component. We just need to replicate that out, and we need to add a little bit of a delay. So to be able to do that, what we're going to do is we're going to disconnect these pins here, and we're going to move this back, and we're going to create something called a timeline. You can double click on the timeline. I'm going to set the length to just be something real short, like 0.3. I'm going to add a single float track. I'm going to title it an alpha, and then I only want 2 keys. My first key is going to be 0, 0, and then my second key is going to be 0.3 and 1. So your timeline should look something like this. So now if I compile and I go back to the event graph, instead of, here, we'll go ahead and disconnect this because we're not going to use that either. And we'll bring this down a bit. All right, so from the set location, we're going to drag this and do the play from start. And we're going to be getting the current location, so we'll hold Control, drag out. Then we need the forward location, so we'll hold Control, drag out. We can pull off the current location into a lerp vector, and then put the forward location in here, hook up your alpha into the lerp alpha here, and then the result of this lerp will actually go into the set world location. And now your update pin is going to be updating this location based on this alpha value, so between these two locations. So it's going to blend the character between its current position and its forward position across some time, which is 0.3 seconds, and you're going to see it kind of jump in between those positions. After the animation is done, we can pull on the finish pin, or the timeline is done, I should say, and then that'll do the delay for where it actually sets the new location and the is jumping to false. So now if I compile and I do this, we can see character moves a little bit smoother. The animation component we'll set up in the next video, so don't worry too much about that right now. But let's finish off the rest of the code for the other keys. So we can highlight all of this stuff here, and I'm going to shift select this stuff here. I'm going to press Control D to duplicate it. And then I am just going to do that a couple more times and line it up as best I can, like so. And then I'm going to basically just take the D key, hook this into here, A key into this one, and then the S key into this one. And we already have the W set up. So there's going to be some slight adjustments with these. So for the S key, which is facing towards us, we want the rotation value to be 0. And if that's hard to understand, you can just come to your viewport. You can see Qbert is looking at us right now, which is where we want him. And you can see his rotation is 0. 0 or 360 degrees, but honestly 0 degrees would be better. So just set that there. Now for the movement, before we move the character negative 100 degrees, so this is the opposite direction, so this would be positive 100 degrees. And because when we build the maps, it's usually the tiles are higher in the back and lower in the front, we don't need them to jump as high. So instead of 150, I'm just going to do 100 units jumping forward. And then I can just hook this play from start, and we can use the same timeline, just like so. Now for the A key, that's facing to the left. So this one's actually going to just be 90 degrees, which is just a single rotation to the left. And then we're not actually moving across the y-axis with this one. We're moving across the x-axis. So this is going to be negative 100. And because this one is a back tile, he's going to have to jump higher. So we want about 150 units for it to be about right. And then we can hook this into here like so. And then for the last one, the D key, that's going to be him facing to the right. So that rotation is actually 270 degrees. So that'll actually get him facing to the right, which let me see if I can. So you can see 270 degrees faces him to the right, 90 degrees faces him to the left, 180 degrees faces him straight back, and 360 degrees or 0 degrees faces him towards us. So that's basically all we're doing. We're just rotating the static mesh. It's kind of like an illusion of movement. So we're rotating the static mesh and we're moving or translating the capsule component. So with that set here, the movement again is going to be on the x-axis. We want 0 for y. And instead of negative 100, we of course want 100. And because this is a forward-facing block, it's going to be lower, so we only need to jump 100 units. And then we can just hook this into here. And then we're basically cooking with gas just with this. The other thing I'll say is make sure on your character movement, your gravity scale is set to 1. If you're using something else, your gravity scale might be a little bit higher or lower. You do want the character to fall with gravity. So if we go ahead and play, you can hit W goes up, A goes left, S goes down, D goes right. So you can move your character around like normal. All right, everyone, we'll cut it here to keep it short, but in the next video, we'll focus on creating the animation blueprint and montage so we can give a little more life to our player pawn as it moves around the map. If you enjoy the series, please leave a like and a sub to help grow the channel, but as always, thanks for watching and see you on the next one.